Hey everyone, I am Pramod. Welcome to the fifth talk in the series Faster, Better, Cheaper Together. It's a series of talks we are doing on software project management. And today we will have with us Sudheer Bandaru, who is currently the CEO of Hivel.ai. And Sudhir is going to be talking about measuring engineering productivity, old pitfalls, and new approaches. So Sudhir is an industry veteran and he has more than 2 decades of experience and he has worked as both a software developer and in engineering leadership roles. He has seen life at startups in various stages and he's experienced firsthand some of the issues that he's going to talk about. And as I mentioned, he's currently the CEO and founder of Hivel.ai, which is a platform that provides insights about how your software team is doing. So before I hand over to Sudhir, one quick thing I should say is we had a great in-person mixer last Friday where there were more than a dozen people and they got to spend high quality FaceTime with a bunch of experienced engineering leaders. So thanks to everyone who attended the last mixer and we're hoping to do more of those. And with that, over to Sudhir. Yeah, one more thing, maybe as usual, you can post the questions, on either the YouTube live stream or on the Hasgeek website or right here on Zoom. So I'll pick up the questions from all three places and please keep it interactive. Sudhir will be happy to take questions, I'm sure. Cool. Over to you, Sudhir.
Awesome. Thank you so much, Pramod. Hello, everyone. Happy to be here. I would like to make this a very engaging conversation as much as possible and make sure it's not a monologue and you get the best out of it. Just as Pramod introduced, I am Sudheer Bandaru. I'm the founder and CEO of Hivel. Here I'm here to talk about the future of efficient teams and how do we kind of club the faster, better, and cheaper. The agenda here is to kind of talk about engineering productivity. How do we make our engineering teams efficient? Why, what not to do, how to do these things. We also have some customer stories towards the end of this discussion, but feel free to interrupt me along the way. Pramod will help us collate the questions and, we'll take some break pauses in between to answer your questions. Yeah. So firstly, to begin with, how many of you would like to improve your team efficiency? I'm like, if you're here on a Friday evening, I can imagine you're serious about this. When I ask this question, I always get a lot of people raising their hands, pretty much everybody. But when we ask this question about, would you like to measure your team efficiency? I see a few people dropping their hands. This is where I'm like, no, the title of this talk that talks about old pitfalls. What are the scars we have been having from measuring engineering efficiency in the wrong way has caused some myths and concerns around engineering efficiency. I would like to talk about some of those things. And if you have any particular questions in your mind, I'm like, feel free to bring them up. Yeah. Talking about this, we always, I'm like, we have seen, some of you may have seen all of these news, I'm like, where top leaders have been talking about uh, engineering efficiency. Mark Benioff says, I'm like, Salesforce workers, that new employees are facing lower productivity. And you also see that Mark Zuckerberg is talking about it. How do we know that, Mark Zuckerberg knows that, who work in person get more done? Google CEO is talking about it. Productivity as a whole is not where it needs to be. These are great. I'm like, these are great, discussion topics. But how do you even know that, the productivity is lower, productivity is higher when you're in the office, productivity is not at where it has to be, correct? This is where I'm like, we wanted to understand where we are operating today and what is the actual potential of the team. When we see this, there is a gap between where they're operating and what is the actual potential is what we are calling as an inefficiency. And the cost of this inefficiency, based on a report, it's over $300 billion in wasted software inefficiencies every year. This is exactly what these people are talking about. And when I was talking to some of these engineering leaders at these top companies, I said, I'm like, how do you know that, the top leaders are understanding productivity? How do you even measure it? How do you even track it? Right? That is what led me to start Hivel. I'll talk more about, how they're doing it. But it also has become this inefficiency thing, just like how we have seen top leaders talk about it. It also has become a very, very prominent topic and a hot topic lately, where every company is saying we need efficient growth. Previously, when capital was almost cheap or free, it was like growth at all costs, or right. People don't want it growth at all costs. Now they wanted like efficiency, they wanted profitability, and engineering is not immune from showing efficiency. When we see these things, we say, I'm like, how do we understand, right? I'm like, what is inefficiency? I'm like, how do we get visibility? We do not have visibility into these inefficiencies, and we are not able to answer few questions like when the CEO is asking or the board is asking, is the engineering team working at optimal efficiency? And most of the time, the responses are, I'm like, oh yeah, we will deliver this project very soon, which means, the assumption is that when you deliver a project on time, it assumes that, the teams are efficient. But that's not the right way, right? We don't want the teams to be burning out to kind of deliver something on time and think this is the efficiency. Or the CFOs who are completely looking into profitability, they answer them like, how do we know our engineering teams are actually working on the right things and they are actually contributing to the revenue outcomes directly, right? CTO is unable to answer. And when the CEO says we need to deliver features faster, CTO says let's hire more people. The questions continue to happen, and our hands are tied in a way that we cannot answer these questions in a very objective way. And when you do not have these visibility, the problems are, it's a profitability problem because now there are enough reports where board and like a lot of data coming from various sources is hinting us what should be the R&D percentage for a particular company to make sure, their teams are efficient. Previously, it used to be growth stage companies used to be somewhere around 30% plus on the R&D spend. Now they're saying, I'm like, it has to be 20% because now you have leveraging AI and all of those things. Then you also have, when you do not have these things, people often miss deadlines. And this is also the beginning of the year. Generally, for some people working on US markets and all Western, where January, February, the fiscal year starts, and they're all hitting their roadmap planning and all of those things. And they say that when they look back, why did we not hit our revenue goals? They say we missed the deadline. We did not get this feature delivered on time. I could not sell it. I cannot meet our revenue goals. This is exactly what we keep saying. Engineers are always busy, but doesn't mean that you're building the right things that the business wanted. Sometimes it could be that engineers are clearing up their tech debt, and the product team and the business teams are waiting for a product to be released, and engineers are like, hey, I cannot deliver these features until I clear this tech debt, right? All of these are the struggles a lot of engineering leaders are facing in today's market, where they're not able to answer using data and they're relying completely on get-based decisions or subjective responses that they're collecting from the team. A lot of times it also happens. I'm like, no, why is the production quality bad? I'm like, why are we continuously seeing production issues? We see that, production issues is the nature of software. But one of the things that we need to get a visibility into is like, do you think is there a better way for us to do these things? I'm like, do you think I'm like the team is some questions people ask? I'm like, is the team capable of building a good software? The problem is not the capabilities of the team. The problem is that the team is not getting enough time to deliver a quality software. And sometimes we don't know why we are not able to deliver things faster. Why are we missing the deadlines? Is it because you're not getting the requirements? Is it because your review process is taking longer? Dependencies, cross-functional challenges? We don't know, right? And coming to performance appraisals, that's the least of the problem we want to worry about. But if you see all the OKR tools, all the performance appraisal tools, I'm like, no, they really work for non-engineering as a function, but not engineering, because engineering is always looking at, did you deliver a particular product or a feature on time? And that doesn't tie to an individual performance, or it's not always tied to an engineer or engineering team solely, right? So there's so many challenges. While we have all of those challenges, I wanted to just pause here for a moment and see if any of you resonate with any of these problems. Have you, I'm like, I wanted to know, if possible, share, I'm like, what is your role, which company, that can get me some visibility into, what kind of audience we have here today, and see that, if you resonate with any of these kind of problems. I'll just pause here for a moment.
Yeah, hi, this is Deepthi. I work at Flipkart in a director of engineering role. And yeah, all of what you said is something that we do encounter daily. I mean, could connect with all the things that you talked about. So yeah, fully resonate with what you are saying.
Great, great. Thank you, Diti. Anybody else?
Hey, hi. I'm Karthik Rajwed. I'm engineering manager at File. It's an expense management software. So yeah, I've been an engineering manager for last 1 year almost. So a lot of problem I'm already facing, and I think a lot of it I might face in the future. So yeah, I can resonate with a lot of it.
Great, great. So see, the thing is, the problem is, I'm like, no, as a human, we are a very data-driven human beings, right? When you are running an organization, the company is trying to look at the stock value, right? I'm like, as a public company, it's very easy to say if the company is performing well or not. And when your company is performing well, you wanted to come inside and go to each of the functions. Say, how is the customer success, right? I'm like, how good is your customer success? You have a metric that says what is your NPS. If you see sales, I'm like, how much did you deliver? It's very easy to say. Marketing, how many meetings did you book? How much of traffic did you get? When it comes to software engineering, what metric can you show that this is how the efficiency of the team is? Correct? Now, all of that said, hey, engineering is an art. We cannot measure it. Productivity is, I'm like, it's more art, more science, right? That though all those discussions continue to happen, but that is not convincing the top leadership, right? Because they wanted to know, how do I get good visibility into all of these things? I'm like, can you help me, right? But when we say it is an art, something, you all are probably, very familiar with this personality here, right? This famous painting. Mona Lisa painting has one price to it, and a Starry Night painting has a different price to it. While one can say, I cannot measure art, even something as literal as art can be measured by the outcome, by how much it was sold for, right? Which means we know that, even engineering productivity can be measured. It's just that we need to be very, very cautious about what not to measure. Like I stated in the beginning of the call, we need to be clear about what not to measure. So let me get all of those things. I'm like, if you're thinking I'm talking about lines of code, definitely that's not the goal. And if it is lines of code, if somebody used it, now with AI, ChatGPT, Copilot, I'm like, no, everybody can be the star performers, correct? We are not talking about lines of code. We are not talking about time spent on IDE, right? Interestingly, during COVID time, there was a funny joke that was happening with Slack. Slack has a feature that when you are not on the system, it takes you into idle mode. And people have downloaded some of the plugins that would move your cursor after 30 minutes so that you don't look idle on Slack, right? It's very easy to game. I'm like, we are not paying engineers, we are not hiring engineers to spend more time writing code. And at the same time, moving to next level, people have relied a lot on story points and estimates and encourage sandbagging, because most of the metrics what people had access to were around Jira and story points. Now, if the goal was, hey, deliver whatever you commit, because a lot of companies use these metrics like say-do ratio, right? Do whatever you said you're going to do. So when you wanted to make sure that you wanted to commit less, right? This is what encourage some companies and some teams to commit less, so that they are always looking in the good books of delivering whatever they have committed. Now, the other companies, I'm like, went on to say that, you need to spend more time in the office, and it doesn't help anything at all. And we have seen that. And a lot of research around the COVID time, people have realized that people have delivered a lot more value, a lot more pull requests, a lot more of code written and delivered, thinking that, people were actually more productive sitting at home. But when we actually dig deeper into the research, they were always delivering more, but it was not of good quality, or it was not actually serving the final purpose. The reason being, these were less collaborative. They were trying to make things fast, deliver things faster because they had more time in hand, but it was not the right features that they wanted to deliver. And they have a lot of bugs and rollbacks because of the poorly thought out features that were rolled out, some of those things. So it's none of these things. We are not talking about any of these traditional things when we are talking about engineering productivity. It has evolved a lot, right? One of the reason, while I personally, as a CTO for over a decade, have relied a lot on Jira dashboards. And we used to have a developer experience team, a bunch of project managers and an army of people. They had the fanciest of the reports. I'm like, any question you ask, they had an answer with the report and a dashboard, which was trending. But none of these really understood or helped us answer one single question: are our engineering teams productive? The reason being twofold. One, manual inputs. Engineers don't like to give the input, and people are writing code somewhere else, and you have to come here and kind of give your story point or something. That manual input, engineers always hated it. The second thing, if project managers were behind the engineers and forcing them to give the story points on time before they start the sprint, end of the day, it's an estimate. How well do we know that it's estimate, right? Estimates of story points is a combination of, to get this, ideally, when agile was bought into the software as a culture, right? Agile culture was bought into software teams. The way we were supposed to give story points was it should be a combination of uncertainty, effort, and complexity. For somebody to give these story points so well, they have to spend a lot more time on agile planning. A sprint planning of 1 hour is not at all sufficient to give this the right way. Agile also talks about all the poker way, or like, where somebody has to give us story points, and somebody has to challenge, why do you need these many story points, so that you understand the depth of the problem and make them write the right story points. When you wanted to push people towards giving the right level of story points using the right way of doing it, it is a process over velocity challenge. You can spend more time planning, but then it'll drop your velocity. Now, agile and people being in a rush to deliver features, they don't want to spend all this time. Any of you play poker in your stand-up calls or when you're doing a sprint planning? Maybe you can type in a bunch of yeses or nos, or wanted to. Right? So then what we are actually coming to now is more of an outcome-driven research based metrics. Let me see. Said, okay, yes. Yeah. See, it is good. I'm like, if you do it the right way, it definitely helps a lot. It's just that the amount of time it takes, and how well people are able to really play this poker in a group setting where you have a diversity of engineers, new engineers versus tenured engineers in the team, senior engineers versus junior engineers, how well everybody is on the same page and how well you're able to do it, right? But now we are trying to talk about, because people haven't mastered some of these things, and the problems remain the same after doing so many different things. We are here to talk about outcome-driven research-based metrics. So why we need metrics, right? Again, while we wanted to answer all of those questions, there are some people, I'm like, they say, I have a small team of 10 people and I know each and everything about what my teams are doing. I run my stand-up calls very efficiently. I know what my teams are going to do. The problem is, as a first-line manager, one may have the visibility, but the challenges, like I stated in the earlier slides, is somebody who wanted at the top level visibility. As a CTO, as a CEO, as a board, right? There are so many layers in between, and this visibility and this clarity is completely blurred as you go higher in the hierarchy. That is why we wanted to make sure, what somebody thinks I have a visibility doesn't solve it. Second problem is, while you may think you have an efficient engineering team, you don't know how your other engineering teams are performing and how you can improve or learn from other best practices from the other teams in the same organization, right? That is where it's about visibility, not just at your level, but how do we carry this and, kind of roll it up all across the organization so that the top leaders have enough data to make very data-driven decisions. Now, the second problem is, we're also talking about some of these metrics. While we have seen that NPS can be a good metric for customer success, or sales can be a amount of revenue generated can be a good metric for sales teams, we do not have a single metric when it comes to engineering. There is no unidimensional metric that will tell the efficiency of an engineering org. That is one of the biggest problem. And if you see this in this example, somebody who is touching, I'm like, a blind person touching an elephant, one place could say it's a rope, somebody could say it's a spear, depending on where you're touching. Similarly, if you're looking at velocity, which is a sum of story points, people say, oh yeah, my velocity is dropping. But what does that mean? Does it talk about quality? Does it talk about this is the final potential of the team, right? Or somebody could say, I'm writing a lot of lines of code. That doesn't help anything, correct? So we cannot really take engineering efficiency as a single metric. and it has to be looked at holistically to get a perspective of the whole overall story. Now, one of the ways that we wanted to really look into this holistic approach is also not through a output way, right? Some of the examples, what I stated about, number of hours in the office or number of time spent on ID, these are all output lines of code. If you are giving a stationary bike, exercise bike to an engineer and, asking them to pedal it, right? Just spinning it faster and saying, I've done 3 miles or 5 miles doesn't help anything, right? Because the output is not about how fast you spin or how much you spin, how long you spin. What you really wanted is the outcome, which is about going from A to B, right? So if you're spinning a stationary bike, it's just like writing lines of code and lines of code without delivering the end user value or even creating an impact. So it really matters the kind of metrics you take so that you are actually focused on the right outcome. That way we kind of go away from all the scars and all the myth that we have about engineering productivity. Now, this is where the challenge happens. Like I just said, it's not a single metric to tell us about the efficiency of the team, right? We wanted to make sure it is faster, we want to make sure it's cheaper, and we want to also make sure it is better. These are the triple constraints. I spoke enough about the problems. I spoke enough about what not to do. I have a question here. Yeah. Any questions so far before I move on to some of the ways on doing the right way to do these things?
Not really a question, but just a perspective. So I come from platforms team, and there, in a lot of cases, it is ultimately not the volume or amount of code that you change, but a lot of effort goes into finalizing the approach or coming up with, say, comparisons, benchmarks, and so on, which is not exactly translatable to, say, a code deliverable. So there, how to measure efficiency, etc., or productivity also in a more consistent manner always becomes a challenge.
Absolutely. I think that's a good segue for us to get into the next part of solutioning. How do we answer those kind of questions? Yeah.
Sure.
This is where it's not just the people on the call and me struggling about these things. Google has been struggling to kind of answer this question. They spent over close to 9 years of research now, understanding how do we measure engineering efficiency. And they have released something called DORA Metrics, DevOps Research Assessment. And this is something that the whole engineering community has been embracing it so well because of the way has been designed. I'm going to talk to you about some of the top four metrics that DORA recommends. One is the deployment frequency. The deployment frequency is how many times, how often are you able to deploy your code to end user as a production, right? Again, when I say end user, it is super clear. If you're having feature flags and pushing it to production, that's not end user. It's about reaching your code to the end user where they are starting to use it. That is the deployment frequency. And the second one is a cycle time. This talks about if you take only engineering into consideration, assuming you got the good of the best of the requirements that enable an engineer to start writing code, how long does it take for the developer to go from the first line of code, writing the first line of code, all the way to releasing the feature? In a simple example, if I have to put this into a different analogy, like a Zomato, deployment frequency is about how many deliveries can this person do versus cycle time is how fast can they do. If you take either of these alone, it doesn't really give you a holistic picture, correct? Because you just say, hey, because you can deliver something in 20% faster, doesn't mean that you're very efficient, because you also need to make sure you're delivering more. This is where in a software engineering life, right, we are looking at the number of pull requests merged to master or releasing end features, versus when it comes to cycle time, it's about the first commit to the final PR merged, because there are so many stages in this whole thing. In cycle time, it is a combination of how long it takes for you first for an engineer to open the PR, then somebody to review it, and then somebody to merge it, right? This is where your whole software development lifecycle comes into picture. Then comes in mean time to recover and change failure percentage. What does this mean? Like, both of them are talking about something around speed and throughput, but we also wanted to make sure we are delivering something in a quality manner. So change failure is like, out of 100 PRs that you have merged to master or released to production, how many of them are hot fixes or production issues? That talks about, if you are saying, I'm like, no, I'm delivering, this is one of the things what I was talking, some of the research showed around COVID time, people had a lot of features, but most of them were, the change failure percentage also was very high because there was a lack of collaboration, there were a lot of bugs happening, all of those things. And the fourth one is mean time to recover, MTTR. The reason we wanted to get a visibility to change failure percentage plus MTTR together to get a bird's eye view and a holistic approach, holistic visibility is, hey, it's okay to have bugs, but how fast are you able to recover if there is a bug? Correct. If you are kind of going at a very fast pace and doing 1,000 deployments per day, it's okay to have 100 bugs. As long as your bugs, you are able to fix them within minutes or hours, depending on the scale and sensitivity of those bugs. Right. Now, if you see this, whatever the problems we talked about, that software engineering measurement and productivity, we are not talking about lines of code. We are not talking about an individual individual performance. Here we are looking at as an org as a whole, and we are also looking at it as a team level goals. And these are all very outcomes, right? This is not an output. If you see, this is not about anything that an engineer would be concerned about. But as an engineering leader, you would get a lot of value when you see all of these four at one place, which your story points or any of these older ways of doing alone will not answer a question like this. Here you get the speed, you also get the throughput, and you also get to the understand the quality of this. That is how these DORA metrics are done. And but to answer your question, Deepti, this is a research across 30,000 plus companies based on this data. Google has a lot of benchmarking information, which I can share it with you offline after the call, where you will have an industry benchmarking to see how your respective company is performing. And there are a lot of nuances to your own business context and stuff. So there are industry level, for its e-commerce versus fintech, all of those industry level benchmarking. Once you have as a company, what should be your industry benchmarking goal, you'll be able to compare each of these teams against those goals. That way, you have a standardized way of measuring productivity, irrespective of the internal processes. If they're 2-week agile sprints or 4 weeks, doesn't matter. Still, you will be able to get these things done.
Sudhir, Pramod here. I just had an observation looking at this DORA metrics and some of the earlier things that you mentioned. I just noticed what we don't have here is like code coverage, right? We don't have code coverage via tests and also things like, what quality checks you do, at the code level, or do you follow these rules and conventions? It just struck me that, that's
Yeah.
actually not part of this. That's quite interesting, actually. Yeah.
See, now that is exactly the output, right? Just because you do code coverage doesn't mean you're going to deliver quality. Now, what is the outcome you're trying to look at? The outcome is when you do a good code coverage, you will make sure your change failure percentage is less. Correct? So as long as you make sure the change failure percentage, it doesn't matter about what are the 10 steps you can take it or no steps, still have a low change failure percentage.
Right, right. And I guess maybe one way to look at this is if the change failure percentage starts to increase, then you go back and say, okay, why did it increase,
Correct.
and do the appropriate.
Exactly. So these are your outcomes. Now there are leading indicators that will tell you what is causing these things and what actions you can take based on these insights.
Okay.
Now, if the change failure percentage is high, some of the actions or insights people could take, or what are the leading indicators for these to be high? People are not doing all this regression testing very well, or pull requests are not reviewed thoroughly. This is one of the common challenge often we see. Hey, we see everybody's rubber stamping something called every pull request. I'm like, as a software engineer, if I get a PR to be reviewed a few hours before the release, I'm going to say, if it's coming from Pramod, I will just say, yeah, this looks great. Go ahead. At Hivel, we kind of start to identify even these, and we call them as flashy reviews. And we often see that, whenever a PR review percentage is 100%, we see that, engineering leaders say, yeah, we are doing everything possible. Every review is, every PR is reviewed. I still don't know what we can do about it. But when we see the flashy reviews, we see a huge percentage of it.
Mm.
The reason is people are not spending enough time and they have no other option. But I'm going to talk about a customer story about this actually towards the end of it that talks about these things.
Sure. Thanks.
Yeah. Moving on, there is an extension to this DORA metrics. I'm like, no, definitely it's been 8-9 years and there's a lot of discussions around these things. And then there is also definitely as the whole concept of engineering productivity has been evolving, there is a future research, the further research that came into picture that talked about few more metrics that became even more wider and more broader, taking into consideration some of the feedback and all of those things. And here we are trying to bring in more holistic nature, talking about satisfaction and well-being. Just because you're able to get your speed, throughput, and quality doesn't mean you're running an efficient organization at the cost of somebody's well-being. Correct? So here we are going to talk about satisfaction and well-being, and then we talk about performance. I will talk about these things: activity, and then collaboration, and then finally efficiency and flow. If you see all of these things, these are slightly abstract level, and each of these metrics or categories of these metrics have to be different for org versus team versus individual. And for two companies, the metric that you pick for performance could be different depending on what you're trying to achieve. But this is an extended version of the DORA research that's done by GitHub, Microsoft, and a bunch of researchers and scientists, understanding how do we kind of take this into feedback and try to show a broader perspective. I'm going to show you what are these kind of metrics in the next slide. I know this may be a little squished here, but if you see satisfaction and well-being, it's very obvious we wanted to know the developer satisfaction. This is usually achieved through some surveys that companies can do, followed by performance. Performance is to understand, are we delivering the features that are reaching the end users and are doing the intended outcome? Right? If you're kind of just releasing a feature, but if the product or feature is not being adopted by the end user, that may not be the right value, right? That is where the impact comes into picture. So you wanted to see what is a code review velocity. Some people talk about story point shipped. Some people talk about customer satisfaction. This customer satisfaction is what I was talking about. You want to release a feature that is doing what it is supposed to be doing. That is where your customer satisfaction comes higher. And it should have a reliability score to make sure the performance, latency, and all of those things are considered. Then comes the activity, which talks about coding time, number of commits. This is again, lines of code is definitely a flag one, but the reason they see this is to understand there are a lot of standardization of data that happens. You cannot have there are some software, some industries where they write huge lines of code. And that is the only way for them to write the code, depending on the nature of these things. And you wanted to kind of measure lines of code in some certain scenarios. That is why it's a star here. But otherwise, for most companies, 90% of the companies or industries, people look at the number of commits and how long it's taking. Now, with the introduction of Copilot, AI Copilot, GitHub Copilot and all, people are able to say, are we able to reduce the coding time? Which means our engineers able to code faster, correct? That is where you will also see if engineers are able to code faster, as a team, you want to make sure you are able to deliver more story points. And when you are able to deliver more story points as a system, if your CI/CD systems and all of them are good, you wanted to have deployment frequency going up. Right? If you see, all of these are very, very interconnected, which is why getting visibility. And the fourth one is communication and collaboration. It's not about I do my own job. I'm like, no, software teams doesn't work that way, right? I'm like, a lot of collaboration and communication needs to happen. Who is reviewing the code? I'm like, is there a knowledge silo? How easily you can find documentation? How long is it taking for these PRs to be merged? All of those things come into collaboration. And then finally, the efficiency and flow, how much time an engineer spends on meetings versus deep work versus shallow work. I'm like, having 30 minutes in between two meetings doesn't allow me to start coding. I cannot even spend enough time thinking about what to write. So that is why we need to make sure we get some visibility into the flow of the engineers so that they are not interrupted. There are some funny stories actually. People said, I wanted to make sure we are reviewing every PR in 1 hour. And that is an SLA one of the organization had. And the moment everybody had this, I'm like, no, they have to stop whatever they're coding and kind of just go review the PR faster so that they are not the bottleneck. Those kind of metrics, when you kind of pull them in a silo, it really brings in unintended consequences where the interruptions happen a lot. And the review time was happening within 1 hour, but the number of PRs were going down because people were not able to open more pull requests. Right. So it is very important on how we balance these things. one of the reasons why you see multiple metrics in each of these categories is to make sure, you pick the right one that makes sense for your respective company, organization, teams, and it is easy to measure. I'll stop here for a moment. Any questions on DORA and space metric? I know this is like a lot of stuff if you're looking at it for the first time. I'll share some links after this. I'm like, no, you can just Google DORA and space. You'll find out. Any questions? I'll pause here for a moment before I go to the next ones.
So, Sudhir, in business metrics, we always have this concept of guardrail metrics, right? For instance, if you have a business metric on, say, uptime, then you always have, a release, then you always have a quality guardrail on, say, uptime, right? So similarly, when we talk about metrics like, say, number of commits or lines of code, how do you ensure that people don't start, gaming those metrics? There is always a way to, refactor and generate a lot of commits, or especially with tools like Copilot now.
Yeah.
How do you bring in those guardrail metrics into the process structurally?
Great. Let me answer that. That is exactly what I have next. One of those things, right? Right after this slide, I'll show you that. What we want is once you get all of these metrics, whatever I showed you, both DORA and space metrics, this is gonna bring in a different level of power and a communication language for engineering leaders, where your sales counterparts are saying, I booked $1 million in revenue, and we cannot just say, I made all these process changes, for example, correct? But what we really wanted to go is into more powerful language, which talks about all these metrics in a way that shows us, I increased the speed by 20%, which talks about how many, I'm like, how fast are you able to do? For example, if you reduce the cycle time from 5 days to 4 days, which means I'm like, no, you're increasing the speed by 20%. And what used to take 5 months will now happen in 4 months. Your CEO or CTO would jump in joy to know that, you have made process changes that would allow you to deliver something in 4 months instead of 5 months. Now, this is the second point, Deepti, what you asked me about. There is something called rework. We measure something called rework. Rework is nothing but a line of code. If it was recently written and modified, we call it rework. If you're modifying a line of code that was written in the past, and this recent and past can be X number of days, usually for a 2-week agile sprint, we mark it as 30 days. So if somebody is modifying a piece of code they have written in the last 30 days, that is rework. If they're modifying a piece of code that was written prior to 30 days, that's maintenance. And if you're writing a new line of code, we call it new work. The research Accelerate book talks about rework on how important it is. And if somebody is writing the code just to kind of do the more number of commits, more lines of code, like to your question, you have to open a pull request, somebody has to review it, and somebody has to merge it. If it is not something that has to go, the whole system should be gaming it, right? So because of that nature, what people will do if they are writing a lot of code, they'll have to go delete it back and then, commit again. When you do these things, I'm like, your rework goes higher. This is the guardrail metric that you're talking about.
Sure, thanks.
Yeah. So this is how we will be able to show, for example, same thing either with if your rework alone goes down by 10%. This is for a US research of a company with 250 engineers, 100K plus salary. The research shows just reducing 10% of rework is a $5 million bottom line savings. Because it is lost opportunity, it is a lot of toil on the engineer to say that, they have to change the same code again and again. One, if you exclude the part about gaming the system, the other reasons why rework will happen is after the engineer starts the coding, they ask for a corner case scenario, and the requirements guy will say, product manager will say, this is not how I thought about it. Let's change the requirements. Or QA feedback comes in and say, this is not working. Or a senior engineer would come in and say, there's a pull request feedback on the review process. They'll say they have to change this for compliance sake or regulations or not lack of readability and all. All of these are the reasons for rework. And getting a visibility into rework helps a lot to understand where your efforts are going. Right. So bringing in this whole culture of data will make engineering leaders more powerful, and it's gonna be a lot more easier to move away from subjective conversations to very objective conversations where everybody is rowing the boat in the same direction. Uh, Moving on to some examples, few small stories about how can we change the way we look at the decisions that we make based on data. If you see Bangalore traffic, and if you see a lot of lanes and there's a lot of traffic, you have two options here. One option is a normal option is to say add more lanes. Let's add more lanes so we can move faster. But if you actually look at it, sometimes you may have to add a flyover. It's like if you're having a huge backlog, engineers are burning out. The CTO goes and says, "I'm like, no, we need to hire more engineers." That's like adding more lanes. Not knowing why we are not able to deliver more, why we are having a backlog, makes us a wrong decision. If you know that the traffic signal, the intersection is a problem, then you know that you wanted to kind of build a flyover. That way you are clearing the intersection. Similarly, if you know review process is a bottleneck and it's not the lack of engineers or bandwidth, then you wanted to empower more engineers in the team to be reviewers. You need to have a better coding best practices, way to review the code automatically through AI tools, and have another layer of human element to review the code, right? So the decisions that you take will be very, very different when you have the data and have visibility into these bottlenecks. Yeah. Then moving on, this whole thing is gonna help us. I'm like, a lot of the times, I'm like engineering leaders, CTOs, VP engineerings, they're all been delivering the projects. But I take this example of Tesla. While transportation of going from A to B has been solved decades ago, one of the reasons why Tesla is so efficient, I'm like, so successful, is because it is about efficiency. We are in that space where engineering needs that efficiency. It's not about just delivering at any cost anymore. And software engineering teams have to go from good to great. And for us to go from good to great, efficiency can be achieved only when you measure it. That is, and measure it in the right way. That concludes the complete idea, what I want to share. I'll spend a few minutes on some of the customer stories on how we have taken this data, these insights, DORA metrics, and kind of solved some of the business problems. One of the
Sudhir, Pramod here. I think kind of related to the customer stories and tying the metrics back. So you mentioned you showed two types of metrics, right? I was just wondering, where are they in the technology adoption cycle? If you can add that also, like in terms of, is it at the early adopter stage or is it starting to pick up? If you can mention that as we go into this. Yeah.
Definitely. The adoption is very, very high in the US right now. We set up a booth back in September in the US at Engineering Leadership Conference, where there were around 900 engineering leaders expected to be there. And 7 out of 10 people knew about these things. And all of them are aware of this. They have starting to use some of these things as a culture internally, or they're evaluating tools like ours, like Hivel, for example, does all of these things out of the box. And they are trying to create budget line items for these kind of two things, because it's a build versus buy, correct? Everybody wants to do this, but building a holistic purpose-built dashboards is hard. So it's more of a I would say probably it moved away from early adopters. It is it's already the next stage. It hasn't reached the third stage or fourth stage of usage yet. But it crossed the chasm of early adopters by now.
Okay.
In India, it's still new.
Okay. Cool. Thanks. Okay, general suggestion to the audience as well, like please chime in with questions. So there is happy to answer them. Yeah, either on the Zoom or YouTube or the Hasgeek website.
Yeah, I'm just checking the Zoom comments if there is any question. Yeah.
Yeah, I think Mayank has mentioned something about how the guardrails will evolve over time. Yeah.
Yeah. Yeah.
Cool. I think you can do the
Definitely. The industry benchmark, Mayank rightly said, I'm like, we don't, while industry benchmark can be a good way for us to understand where we are supposed to be, the way when we kind of work with any of the clients is to say that, hey, before we kind of reach the benchmark, there are so many different components that come into the picture, like the team composition. If a company like Amazon or Flipkart is releasing 1,000 times a day, we cannot release it if it's 100 engineers, if our CI/CD is not designed for that. Or a QA team, if you have a manual QA team, if you have automation QA, right? Versus there is a different culture where the developer is doing the complete testing themselves and they're an end-to-end owner of from code to release, right? So we cannot really reach the industry benchmarking. All we need to know is, can we find the bottlenecks and can we be a better version compared to where we were yesterday? That is how I would take with a pinch of salt when you're looking at industry benchmarking. And the second thing is it's an average of across companies while it is an industry. So that is why thanks for flagging that. Yes, industry benchmarking should be taken cautiously.
We have got one question on YouTube. So Abdul is asking, how do we get the rework code statistics?
Rework code is we have to scan through the code to understand who wrote the code and when they wrote the code. And then once you know when the code was written, if it was written recently and modified, it is rework. And if it was written a month ago or 6 months ago, and if it was modified, it's maintenance, right? Refactor, that's by definition goes like, you're touching or modifying an older piece of code is refactoring. Again, when I say modify and delete, in the world of Git, modify or delete, both of them are same.
Okay. And I guess maybe Abdul probably also meant, like, is it like, part of some tool, or is it generally like, easily done, or yeah.
It can be written internally, build a script, understand. I'm like, do a git blame or something, and try to understand who wrote. I'm like, it is an effort to get these metrics out of the box. Um, yeah,
Cool. Abdul, I hope that answers your question. Yeah, thanks for it. Yeah.
cool. So moving on to one of the examples here. For one of the companies, they had a lot of production bugs, and engineers were burning out. Definitely, when you have production bugs, it's not only the effort, but it's also anxiety and pressure. Correct. When you also have production bugs, there is also a customer NPS impact because the software is in the hands of the customer and some customer has been impacted. When you do these things, when we see these things, we said, how do we fix this? As part of looking at the data in a very holistic way, we realized there were a lot of unreviewed PRs. When you have a lot of unreviewed PRs, definitely low quality releases happen. And when this happens, there is a lot of context switching because a developer has been assigned a certain set of tasks as part of the sprint planning. And they have been switching between their roadmap items and what they have planned all the way to something that is a bug. And most of the times, these production bugs may not be completely from your recent memory, right? Sometimes these are the ones probably took 3 months or 6 months before somebody wrote it. It could be the same engineer or a different engineer. And context switching is another very, very interesting area, something that we surface actually, which shows an engineer cannot be context switching too often. Every time you context switch, you lose the flow, one of the space metrics that talks about efficiency and flow, and this kind of impacts the overall productivity. And then when you see this, definitely the engineer burnout happens. But what we have actually seen with the data, we have taken a very data-driven approach where we said over a period of time, August through January, we reduced the unreviewed PRs completely and also made sure we are not doing a flashy review and making sure the time the engineers, senior engineers were spending time on the review, that went up. If you see the review time in hours went up. The reason is we are slowing down. This means you are kind of spending more time to improve the quality of the deliverables, which means you can only release less features. If you see the deployment frequency per day has gone down over a period of time. And when this happens, this is directly correlated to the number of production issues, which is nothing but the change failure rate that went down. This is exactly we said where what we are trying to do in simple words is go slow, review better, and then improve your quality, reduce the bugs, and improve the NPS. If you have to kind of win an argument like this without data, it really becomes a hard sell because you cannot say, I'm going to take less story points for the next 6 months to make sure, we are doing a thorough code reviews to make sure we can reduce the production bugs. Having a data makes this whole discussion a lot more easier and very efficient, and everybody is looking at it with a uh, proper goal in mind. I just see one question. Yeah. Good. Mayank is adding something around rework. And then moving on to second story. Any questions about this story? All right. There is another company in South America. They were frequently missing deadlines and definitely more production bugs. It's not the same data for the same problem all the time. While the problems could seem similar, the underlying factors could be very different. This is something what we have seen. They were having the PR sizes to be very big. And one of the things that we have noticed with our data also, when the PR is under 400 lines of code, we see the review time happens in 20 minutes. When the PR is greater than 400 lines, sometimes 5,000 lines, can you imagine what that review time would be? We have seen complete extreme opposites. Either people rubber stamp it, oh my God, I don't want to see this, or I'm in a rush. This is too big. I'll just say yes and wait for a production bug to happen. Or I don't want to touch this PR and review it right now. I'll let somebody else pick it up. Or I don't have time to spend like 4 hours on this. I'm writing code. Let me wait. Right? Either of these way, your review time increases badly or quality is impacted, which is why your PR should be smaller. When you have a long review time, you can only release few, right? Your review time is impacted. And when you can only review because of review did not happen on time, people miss the deadlines. We taken a solution here where we kind of reduce their speed and allow them to ship faster and reduce the production bugs almost by releasing more features. All we have done is we have brought in a visibility into say all the pull requests to be under 400 lines of code. 400 lines is a slightly good industry standard, a reasonable standard. I've heard some top companies where they have gone to a stretch to say that, a PR should not be more than 80 lines of code. All PRs are only 80 lines of code max. That is how they kind of push things faster. We come in with short PRs, faster review time, better quality, and ship faster. So that's the second story. All this said, right? I'm like, no, to one of the question Pramod asked, I'm like, no, how much of the adoption is there? There are so many different objections people bring to the table. People say, what about people who are writing database queries? What about people who are writing infrastructure? I'm like, what about the complexity of the code? How are we taking complexity of the code into picture? How do we take the documentation into consideration, right? All of these are the standard objections it comes into people's mind. I'm like, how can we avoid engineers gaming the system? How do we build guardrails around it? This picture is a very interesting picture. Like, when the first automobile was invented, the people were said, what? I'm like, it can go fast on the road and it could hurt somebody or kill somebody. And there used to be a man in front of this automobile carrying a red flag. The whole the whole aspect of going fast because you have an automobile is completely lost when you do that. So every rose has its own, every new tech has its own red flag, but we have come a long way since the invention of automobiles, and we are talking about completely self-driving cars. So same way, this has been a decade-old problem, multiple decades, and we've been fighting with these problems for decades now. And I think we have a great solution that is very, very addressing all our concerns in many ways. I think there's a long way to go, and I think the first step of bringing in data to bring in visibility into your teams is the first step, which can solve probably 80% or even more than 90% if done right. But getting into that culture is most important. I'll stop here. We have some revision of takeaways, but I'll open the floor for any questions.
Hey, Mike, you want to clarify the remark that you're making about one way to measure rework?
Yeah, just building on top of what Sudheer was talking about, think of rework as the frequency of change to any particular file or module. So when Sudheer was talking about writing a script, an easy way to do that is to start with an SHA of the file in question and do a scan at a module level. There are different markers that one can use, or annotations to say that, okay, this is the beginning of a function or a module, and calculate an SHA1 at a sub level. And every single time there is a commit or a change to the top level file, you update your metric basis when it was originally committed or when it was changed. By this way, you can calculate the mean, mode, and median of the rework, and that's where you start. That acts as your baseline, and then you start measuring it and saying, hey, we want to reduce the amount of rework that is happening over a period of time. It is a proxy for the stability of the code that you're writing. It could mean one of two things: either the requirement itself was not clear, or the code quality wasn't as good as expected.
Yeah. Extending on that, one of the a couple of reasons why the rework could happen. One of the reason could be the code quality, which means can be measured, or the closest proxy could be the number of bugs raised against the particular ticket. Or if it is a code review feedback, you can see the number of comments. One of the things that we also do with the review comments is we categorize the comments that go into a particular PR and understand what is the PR talking about. Are these PRs talking about readability? Are there controversial pull requests, which means when a senior engineer says, go change the code, junior engineer could potentially say, it's working on my machine and it's working. Why do you want me to change it? Because software, some of these are opinionated frameworks and there is no right way to do it, right? It's more about some of those things. And the other proxy to know if the requirements are changing is to see the number of comments on your Jira or project management tool. So these are the closest proxies to understand what is the cause of rework.
By the way, this was an answer to Ahmed's question on the YouTube channel.
Okay.
Yeah, that was Abdul's question actually. Yeah, so maybe one more related follow-up regarding the customer stories and adoption, right? Like, are there, like how long does it take for a company to, typically transition into this kind of working, or is it like months or like 6 months, or and are there any experience reports out there which people can read?
Experience reports, I don't know if something exists, but if it is first of all, the choice is no build versus buy. To build visibility into all of these tools, it's a time-taking process. Again, depends on the size of the team they have for analytics and all. And all of these metrics, even getting out of from something like a Power BI or Tableau, may not really solve the problem, because you need a purpose-built dashboards and analytics to solve some of these things. Generic dashboards will not solve the problem. Second, once the dashboards assume all of this data exists, Hivel does exactly this. Right out of the box, we connect to your Git and project management tools like Jira and surface all of these dashboards right out of the box. We pull the last 60 days of historical data and show this is what is happening. And then people bring in some of the configuration settings, based on their internal processes, to say, this is the branch where we do the review process. So they configure some of those things. So once that is done, in a buy case, they have the data up and running within 2 days max, and make any process changes. Now it starts from the top. Usually the CTO and a TPM, Scrum Master, these are the people who are involved in the process for the first set of metrics. And then the adoption goes to the second level, who is a direct reports to the CTO or a VP of engineering. And then from there, it goes one more level down. It stops at a managerial level. It doesn't go all the way to the individual contributor, because most of these are team-based metrics, not individual metrics, where the team are trying to put some of these companies like Splunk and all of them, they're actually putting all of these dashboards on the TVs in front of right next to each and every team. They'll have a screen right next to them, and they're kind of flashing these metrics out there. So the overall time, first, if you have all access to all the metrics through a SaaS software like Hivel, it will take probably 1 month or 2 months for the people to understand these metrics, familiarize themselves, make any process changes and stuff. So 1 to 2 months is a good time for them to start to see and start to take actionable takeaways from these metrics and make process changes internally.
Okay, thanks. Yeah, that was very useful information. So I
Just
think
to add one more thing to what Sudheer was saying, one of the key practices is to review these metrics in your retrospectives as well as your postmortems.
Yes.
Most organizations would have some incidents, whether they are user-facing or internal. So whenever you review your incident, take a look at these metrics, as well as, of course, in your retrospectives, if you're following sprints or any kind of reviews that you're doing at an MBR level or a quarterly or half-yearly level. Make it a habit to review these metrics there.
Most of our large customers have a cadence built around these things where reviewing these metrics is part of their workflow. First line managers are looking at these every week. Next level managers, directors are looking this on a bi-weekly basis. And the CTO is looking at all of these metrics at the org level on a monthly basis. So they have a designed cadence, and there are different level of metrics that each of these meetings are covering. And what actions they're taking, they come back next month and look at the how all of these process changes have impacted positively or negatively to those metrics.
Cool. I think with that, we are almost at time. So thanks, Sudhir, for a fantastic talk. And I think you covered a lot of new concepts and new information, new user stories. I think people are probably still processing some of what you're saying. So if I'm not wrong. And thanks to everyone who participated for the questions and for the clarifications. And yeah, to everyone, just feel free to post more questions either on the Hasgeek website or on the YouTube. We'll try to forward it to Sudhir and get his answers. And yeah. Thanks to Hasgeek for hosting this as always. Thanks so much.
Thank you so much, everyone.
Good. Bye.
Bye.